Hello, my name is Imam Frank, your regular tutor. I'm still in the series of teachings, and in this package I'm going to look at Surds and Surdic equations. So I urge you to bring your book, your Bible, so that you can jot down the important points I'm going to give you about Surds and Surdic equation. At the end of the teaching, the students should be able to define Surd. They should be able to do the rationalization of Surd. They should be able to know the laws of Surd and how we carry out operation of Surd. They should be able to know the square roots of Surdic expression. These are the objectives. Before we start about Surd, I'd like to take us back to what we call rational and irrational numbers. This will help us to understand what Surd is. Rational numbers. Well, these are numbers. These are numbers. As real numbers. These are real numbers that can be expressed in the form m all over n, where m and n are real numbers. Example 20, well, 3 over 4, you have 16, and so on. So we also look at rational numbers. So these are numbers of the form 3, and we have 5, 5, etc. So if a number is not rational number, then it is irrational number. Now you observe that in this irrational number, square root of 4 is not there, square root of 16 is not there, square root of 25 is not there. This is because these ones are perfect square. If I have square root of 4, if I square it, it will give me 2. If I have square root of 3, square root of 16 will give me 4. Square root of 25 will give me 5. So but these ones cannot give me a real number. They will give me in decimal. So these ones are irrational number. So now what is Surd? Definition of Surd. Definition of Surd. Surds are square roots of rational numbers that are not perfect square. Got that. So surds are square roots, square roots of rational numbers that are not perfect square. You can see that these ones we call it surd because they are not perfect square. So these are surd. Now let's look at rule of surd. You have rule of surd. So one, root A, if I have root A, where A is a surd, plus root B, it is not equal to root A plus B. This one is not equal to this. Number two, root A minus root B is not equal to root A minus B. I also have that root A divided by root B will be equal to root A all over square root of B. Now I have another one, very important, that root A times root B will be equal to root AB. That is, division and multiplication will be equal to this. That is, this divided by this will be equal to this. And then root A times root B will be equal to root AB. But for root A plus root B, it is not equal to that. And root A minus root B is not equal to that. Now, we are going to look at another subtopic. So we are looking at rationalization of surds. The rationalization of surd is done when the denominator of an expression is in fractional form is a surd. So we do it when an expression in fractional form, the denominator is a surd. So we do that, we do rationalization. So this is the multiplication. This is done by multiplying the numerator and the denominator by the surd in the denominator. So if we do that, we see that is rationalization. Now look at this. We have examples here 1 and 2. Now solution. I have 1 plus root 2 all over root 2. So what I will do to rationalize this surd, I will multiply up by root 2 and also multiply down by root 2. So if I have expression in this form, I cannot leave it like this. I have to multiply up and down by this root in the denominator. So that will be, if I do that, 1 times this will give me root 2, and then this times this will give me 2. How? Because square root of root 2 times square root of root 2 will be 2. Remember our rule of surd. You see, root A times root B will be equal to square root of AB. So what we need is, now that I have root 2, so I have root 2 times another root 2 will be equal to square root of AB, that is 2 times 2, which is square root of 4, and it is equal to 2. In the rule, anytime you use a square root of a number and type the same square root of a number, the answer will be that number inside the square root. So that is how it is done. Now we can now see why I have 2 here. That is, this 2 times this 2 will give me root 4. And if I square root that root 4 will give me 2. The same thing happens. If I times this with this, I will also have 2. So the answer will be root 2 all over 2 plus 1. If I keep it this way, it's correct because this 2 is dividing everything here. So root 2 divided by 2, and then 2 divided by 2 here is 1. So that is how we can do it. It's very simple to follow. And then the same thing can happen here. You multiply this side by 4 root 2, multiply that by 4 root 2. But remember that 4 root 2 times 4 root 2. You see, 4 root 2 times 4 root 2. 4 times 4 will give you 16. And then see this one, root 2 times root 2 will give you 2. So that is what we will do. And then you have 32, the downside. Times the up, times the down. That is exercise for you. Now, I will look at another subtopic that we are going to take. So, we are looking at similar sort. Now, these are sorts. These are sorts that are multiple of the same sort. Example, if I have 3 root 4, 2 root 4, 5 root 4, and you can see that they have the same sort. So now, for instance, if I want to carry out operation, maybe addition of this sort, we have 3 root 4 plus 2 root 4 plus 5 root 4. So what I'm going to do is, I'm going to add this 3 plus this, which is 2, which is 5, plus this, and this 10. So the answer will be 10 root 4. What this thing means is that it's just like having maybe 2x plus 3x plus, okay, let me change it to be in unison with this, plus 5x. So look at this root 4, root 4, root 4 as x, x, x. So what will you do? You add this to this, and you get 5. You add it to this, you get 10x. So that is how it is. A similar sort, when you have the same sort, written like this, you only pick this one and this one and call it 10 root 4. So that is how similar sorts are done. And so, as I'm going to take example, we'll see how you can use it in solving problems. The example is like this. Evaluate 20 root 3 minus 15 root 3 plus 2 root 3. Number 2, 2 root 24 minus 4 root 54 plus 2 root 150. So, solution for the first one, we see that 20 root 3 minus 15 root 3 plus 2 root 3 will be equal to, we have 20 here because they are root 3, root 3, root 3 because of similar sort. So 20 minus 15 will give us 5, and then 5 plus 2 will give us 7. So the answer is 7 root 3. So simple as that. Now let's look at number 2. Question 2. Now question 2, we have 2 root 24 minus 4 root 54 plus 2 root 150. So what we are going to do is to express these ones to be in similar sort. That is how we solve problems like this. So this one, I can write it like this. 2, which is this 2, times root 4 times root 6. You see, 4 times root 4 times root 6 will give you root 24. because of the rule of sort that says that root A times root B will be the same as this. Minus 4 times, I will also break this one, and I know that root 9 times root 6 will give me root 54 plus 2. Then I want to break this one. I know that root 25 times root 6 will give me root 150. So what are we saying now? Well, this is a perfect square. So if I square root this one, I'll have 2. So 2 times this 2 will be equal to 4 root 6 minus. Now this is a perfect square also. So if I square root, I have 9. And 9 times, I have 3, because this is root 9, I have 3. So 3 times this will give me minus 12. 3 times minus 4, minus 12. Then I have root 6 plus, this is a perfect square also, 25. So square root of 25 is 5. 5 times this will give me 10. Then I have root 6. Now look at it, how we express it, return to similar sort. So that I can now see 4 minus 12 will give me minus 8. Minus 8 plus 10 will give me 2. So the answer becomes 2 root 6. That's the answer. So that is the use of similar sort. We can break sort so that they can have similar sort, and then we add them or subtract. So the next one we are looking at is conjugates of sorts. Two sorts are said to be conjugate of each other if their products give a rational number. Example, if I have A plus B and A minus B, A plus B is the conjugate of A minus B, and vice versa. That means A minus B is also a conjugate of A plus B. This is used in the rationalization of the denominator of sort in fractional form. If a sort in fractional form, and then the denominator is maybe sort and plus sign is there. You know, the other time we were looking at denominator that has only sort. In this one, if it is in this form, then we will look for the conjugate of each other. So we do that by multiplying the numerator and the denominator by its conjugate. Example, we are asked to evaluate this sort, this expression, and then this Surdic expression. So let's take the solution. For the first one, we have root 3 minus root 2 all over root 7 plus root 5. So what we'll do is to multiply the up by the conjugate. So what is the conjugate now? It will be root 7 minus root 5 all over root 7 minus root 5. It's just that. So we can now see that this is the same as this times this. So we use this and times this. Then we have root 21 as root 3 times root 7. Root 3 times root 5 will give us root 15. Root 2 times root 14, root 7 will give us minus root 14. Then root 2 times root 5 here will give us plus root 10 because of minus and minus. Then when we go to downside, we also see that root 7 times root 7 will give us 7. Root 7 times root 5 will give us minus root 35. Now root 5 times root 7 here will give us plus root 35. And so root 5 times root 5 will give us plus root 25. Of course, that is 5. Now it is the same thing as root 21 minus root 15 and then minus root 14 plus root 10 all over 2, because this will cancel this minus and plus, that will go. Okay, then 7 plus 5 will give us 12. So if these sorts could be expressed in a way that 1 is a perfect square, we can also further simplify it. As it is, you can see the operation, how we do it, using conjugates at times to each other, so that the numerator now become real number. It's not in Surdic form again. So that is how it is done. You can now on your own try for number 2. It's just by multiplying this, that is times 2 minus root 5 all over 2 minus root 5. So you can continue here. That is an exercise. So let's look at the next topic, square root of Surdic expression. We are looking at square roots of Surdic expression. Example, find the square root of 12 plus 2 roots 35. Number 2, 30 plus 12 root 6. Let's take the solution. For the first one, we have 12 plus 2 roots 35. Now, let root n plus root n be the square root of 12 plus 2 root 35. We will assume a root m and root n. We can use any other letter where m and n are real numbers. They are real numbers because we don't know the number, but by the time we solve, the number will come out. So if we do that, it means that root m plus root n is equal to 12 plus 2 root 35. Now, we are going to square. Squaring the left hand side, because it's a square now, so we want to square here. We have root n plus root n squared will be equal to 12 plus 2 root 35. So if that is done, we are going to open this bracket now by binomial expansion. So we will have root n squared plus 2 root n plus root n squared will be equal to 12 plus 2 root 35. So we can see this by binomial expansion. By binomial expansion, you have it this way. So that this one now becomes root n times root n, which is m, plus 2 root n plus root n times root n, which is n, and it is equal to 12 plus 2 root 35. So, but from here we can see that m plus n is equal to 12. Call that equation 1, because it is real numbers. And I told us that here is also real numbers. And then we also see that 2 root n is equal to 2 root 35. So this is in the same form with this. Call this one equation 2. Now I'm going to divide equation 2 by 2 so that I can remove this one. Then we'll have root n will be equal to root 35. And so in mathematics, if you have something like this, square root, The next step we are going to take is to square both sides. Squaring both sides, we will have root mn squared to be equal to root 35 squared. Of course, that will give us that mn is equal to 35. So this one now becomes original equation 2 now becomes like this from the original one that we have there from here. So we have developed it to become this. Alright. Now from equation 1, see equation 1. Equation 1, m plus n is equal to 12. From equation 1, m will be equal to 12 minus n. That is, if I take this one to this way, I will have that m is equal to 12 minus n. And if that is done, I'm going to substitute. Substitute m is equal to 12 minus n in equation 2. In equation 2. And so, in the place of n, I'm going to put 12 minus n in equation 2. So, we have n 12 minus n will be equal to 35. If I do that, so this side is giving me 12n minus n squared, because this side is giving me n squared, is equal to 35. But it is the same thing as writing this way. If I take this one to this side, and take this one to this side, I mean everything here will be 0. Then this sign will change. So we have n squared minus 12n plus 35 is equal to 0. So we can now use quadratic equation now to solve this problem. In quadratic equation we can solve it. We look for two numbers such that if we add the two numbers we get 12. We multiply it we get 35. And these two numbers are minus 5 minus 7. So we can see n squared minus 5n minus 7n plus 35 is equal to 0. If that is done, we can group them. How we generally solve quadratic equation. So n squared minus 5n, we group them, minus 7n plus 35, also group them. Everything is equal to 0. Now here something is common, so n is common, so we'll have n minus 5. Then here 7 is common, I will have n minus 5, because 7 times here give me this is equal to 0. Meaning that if I pick this outside one, n minus 7 is equal to 0, or the brackets they are equal, so I can pick one. N minus 5 is equal to 0. Now, what it also means is that n is equal to 7, because I'm going to transfer them to this side, or n is equal to 5. Therefore, now we have seen that n is equal to 7 or n is equal to 5 will be equal to 12 minus 5, so n will be equal to 7. So we can see that m is 7, m will also be 5, or in the other side n is 7, n will also be 5. Now what it means, we can conclude that therefore the square root of 12 plus 2 root 35 is root 7 plus root 5 twice. We times it 2 times. But if you have calculator, when you press root 7 plus root 2, and then you press square, the value that it will give you will be the same when you press 12 plus 2 root 35. So that is what we use sort to do. You can see how we manipulate it and then the whole thing came out. And the manipulation is not magic. The manipulation is not magic at all. Based on the rule, we solve them one after the other and we get it. Now, I also want you to take the number 2 exercise, your exercise, and practice it. Follow this step. They are very simple. Follow this step. They are simple. Now we'll look at the next subtopic, Surdic equation. Sometimes we can be asked to solve equation in this form, and the equation contains surds. So it's very simple to solve. And the solution, we have 2x minus 3 minus root x minus 2 is equal to 2. And the first thing I'm going to do, I will take this one to the other side. And if I do that, I will have square root of 2x minus 3 will be equal to 2 plus square root of x minus 2. Because this one is crossing to that side. And when it crosses, the sign will change to positive. Now, I'm going to square. Squaring both sides. If I square both sides, I will have square root of 2x minus 3 square will be equal to 2 plus square root of x minus 2 square. Then this one, square root of 2x minus x minus 3 times square root of 2x minus 3 will give me 2x minus 3. Remember from our rule of sort, that when you use the square root of a number times the same square root, the answer is that quantity inside the square root. So, by this one, by binomial expansion, you see binomial expansion is very important. You can also watch binomial expansion, is there in your package, so that you understand this process, how we expand it. So this place, we will have 2 squared plus 4, that is 2 times this 2 of this, x minus 2 plus x minus 2, this square root. So we have 2x minus 3 to be equal to 4 plus 4 square root of x minus 2 plus x minus 2. Because when I square this one, it will give me this. Alright. Now, I can now also see that 2x minus 3 that I have here. Now for this one, see what I have, minus 2 minus 2. So what I have here, I mean minus 2 plus 4. So what I have here is 2. 2. And then I have x here, standing alone. X minus 2 plus x. Anyway, so what I'm going to do now, I will bring x to this side. I will bring x. So if I bring x, I will have 2x minus 3. Then this one can come here. It become minus 2. The other one can come here. It become minus x is equal to 4 square root of x minus 2. Understand the concept? We are just taking this one to this side. We take this x to this side. We cannot take this one now because it is joined with this. So if we do that, we see that we have 2x here. 2x minus 1x will give us x only. So x minus 5. X minus 5 is equal to, we have here, is equal to 4 square root of x minus 2. Now, if that is done, we can now square both sides. we can square both sides of this. So if we do that, squaring both sides, we will have x minus 5 square will be equal to 4x minus 2 square. And so what we will have here is we have x squared minus 10x, that is 2 times x times 5. 2 times x times minus 5 is this, plus 25 will be equal to 16. So this 4 is raised to this square root, and then this one is also raised. So we'll have here x minus 2. Why? Because this square root times square root will give us this. Now if that is done, we also have that x squared minus 10x plus 25 will be equal to 16x minus 32. That is using this to times this, using this to times this. The next step we are going to take is we are going to use x squared. Now this one here is 16. So we can bring it inside. We have minus 26x, because by the time 16x crosses to this side, it turns to minus. So when we meet with this minus 10, it becomes minus 26. Okay, now I'm going to bring this one to this side also. They will turn to plus. So we'll have plus 54. Yes, because 25, 32. 7. Okay, plus 57 is equal to 0. Alright. Numbers that when added gives us minus 26 and when multiplied gives us 57. But if we don't want to use that, we can use the almighty formula in quadratic equation. So we know that our x, to get x, will be equal to minus b plus or minus square root of b squared minus 4ac all over 2a. So if we use that, we know that x will be equal to minus b. This is b. So we have 26 because this is minus. So the minus will make this one plus or minus minus 26 squared minus 4 times a is 1 anyway, times c, and c is 50, 57 all over 2a, 2 times 1. So this will be the same as 26 plus or minus square root of 26. The square of 26, that is 26 square. The 6 square will give us 676 minus, now we have 4 times 57 times 57 is giving us 228. Alright, all over 2. Now 676 minus 228 will be equal to 448. So let's continue here. 26 plus or minus square root of 448 all over 2. So we'll have 26 plus or minus square root of 448 will give us 21.2 all over 2. So x will be equal to 26 plus 21, 47.2, 47.2 all over 2, or when we go to the negative side, in quadratic equation we take this positive, as 26 plus 21 will give us 47.2. 26 plus 21.2. Now we also go for the negative side. 26 minus 21.2. It will give us 26 minus 21.2 will give us 4, or x will be equal to 4.8 divided by 2. Alright. Meaning that x from this first one, that is 47.2 divided by 2, is giving us 23.6, or x will be equal to 4.8 divided by 2 will give us 2.4. So we have got the values of x. X will be 23.6, or x will be 2.4. And if you fix that in this thing, you see that they are going to be equal. To fix that here, they will be equal to 2. So that is how we can solve problems of sort relating to this aspect of Surdic equation. So another example of problems concerning Surdic equation: if the area of a rectangle is 7 times 2 plus root 2, find the width of the rectangle if the length is 3 minus root 2. So let's take the solution. The first thing we should know here is the formula for area of a rectangle. Area of rectangle is given by length times the breadth, or you say width. That breadth also means width. So then we are given that the area of a rectangle is that. So meaning that we are going to fix 7 2 plus root 2 here as the area is equal to, and they say find the width of the rectangle if the length is this. So the length here is, we are giving length. So length is 3 minus root 2. So it's only b that we are not giving. So we want to find this breadth now, or width. That is to say, our breadth will be, or width will be 7 2 plus root 2 all over 3 minus root 2. And now you can see how this problem results in a situation where we are going to multiply the numerator and the denominator by the conjugate which we have learned. So that is how we are going to do it now. So we are going to multiply the numerator and the denominator by the conjugate of 3 minus root 2. Of course, that is 3 plus root 2. That is the conjugate. So what we do now is the breadth will be equal to 7 bracket 2 plus root 2 all over 3 minus root 2 times 3 plus root 2 all over 3 plus root 2. Yes. So if we do that, we can now multiply it out. But before that, let me multiply this one to get 14. Multiply this one to get plus 7 root 2. I'm opening this bracket all over 3 minus root 2 times 3 plus root 2 all over 3 plus root 2. That will be easier. I can use 14 to times 3. So 14 times 3 will give us 42. Now 14 times root 2, we have 14 root 2. Now 7 times 3 will give us plus 21 root 2. Yes. And so 7 root 2 times root 2 will give us 7 times root 2. That is plus 14. All over, we use 3 times 3. 3 times 3 will give us 9. 3 times root 3 we get plus 3 root 2. Then we say root 2 times 3 will give us minus 3 root 2, and then minus root 2 times root 2 will give us minus 2. Of course, this one and this one will go. So we have 9 minus 2. So this is the same thing as now this plus this, 42 plus 14 will give us 56. Then we have this one, similar sort. Here we have 14 and we have 21, and this root 2 and root 2, they are similar sort. So we have plus 35 root 2 all over 9 minus 2 is 7. So it's the same thing. If we divide here by 7, 56 divided by 7 will give us 8. 35 divided by 7 will give us plus 5 root 2. So that is the width of the rectangle. The width B of breadth of the rectangle is 8 plus 5 root 2. So this is where we are going to end, and urge you to get this package and keep it well for further use. Introduce it to your friends. It will help them in their studies. Thank you very much.